Hi there once again, and welcome to another Expresso mechanic tutorial. And in this one we're going to be producing what you see on the screen, and I'm calling this a collision avoider. And in order to achieve this, we're going to be using the Python tag. So it's a pure Python tutorial. And as you can see, our little green dart is moving around and then choosing a new direction when it gets to the inner edge of the ring of cubes. Hopefully this will be quite an interesting tutorial to do, and there's certainly some useful information in this one. That's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. We'll start by bringing in a cube and make it 20 by 20 by 20, as we so often do, and I'll put a little fillet on it, 0.5. Okay, so I've got my first cube. The next thing to do is bring in a second cube. Again, we'll make this 20 by 20 by 20, but we won't put the fillet on it this time. I'll make the first cube invisible, so I'll just switch it off and make it disappear. We can see that our second cube, we've got our axes here, so our Z is facing along the world Z, and that's fine. Now this particular cube, if we go into our top view, so F2 and then hit O to take a look at our cube, what we can do is make this one editable. So hit C, it's now editable. With our brush selection, make sure that visible only is checked off, because we want to click here and click here with the shift held down. And then we need to reach for our scale tool and just bring these together so that we form a dart. And that's looking good. We can go back to our model mode and we'll make the cube green as I did in my sample file. That's fine. So we've got our avoider, and we'll call it avoider, and that's ready to go. The next thing to do is work with our cube here. We'll just make this one invisible for a little minute, and again here with this particular cube we'll just change the color of this. Oh, I made this something like a sort of a purplish color, I think. So we want blue, we want something like sort of lilac-y kind of color. That sort of thing was fine. I think that'll be fine for that. And then what I did with this, I threw it into a cloner. So we'll grab a hold of one of those with the Option key held down, and we've got our cubes in there. At the moment they've gone to the cloner's color. That's fine. They won't ultimately be. So what we'll do with this is, in our object tab here, the mode we'll set to radial. Our count needs to be 50 and our radius 200. And we've got our ring of cubes. We can then hit C to make the cloner editable, and we've got the cubes there. And that's all good. Let's just make sure, oh, we've gone back to there, it has changed them. Okay, let's just change their colors then. Select them all, and we'll bring the color back to what we had before. Something like that. That will do fine. Okay, so we can call this barrier and bring back our avoider. And we've got our initial setup ready to go. Moving on from here, we can bring in a null and call it Python. Give it a Python tag. We'll switch to a scripting layout. Just pull this in slightly and open in Python editor, and we're ready to start doing some coding. The first thing we need to do is clear all of this because we don't need it. And then we can come to line 8 here and say comma, and it will be random because we want the random module. We've got that sorted out, and we can think about where we're going next. Well, we need to bring the avoider, and we also need to bring the barrier and its children into the code. So we can say avoider is equal to, and then we can say doc.search object brackets single quotes, and it will be avoider with a capital A. thereby bringing this in. We can go for the barrier next. So barrier is equal to, we might as well copy this line and just paste it here, and then replace avoider with barrier. Fantastic, so we've got it that far. And then finally for our objects, we can then say cubes is equal to, and it will be barrier dot get children, open close. And that will bring all of our cubes into a list. Moving on from here, we'll bring in the ubiquitous frame variable. So frame is equal to doc dot get time, open close dot get frame, open doc dot get fps, open double close. And that will bring in our frames from the timeline for anyone who doesn't know. Moving on from here, we'll select our Python tag, and in our user data we'll add user data, and we'll simply say spline, and it will be a spline data type. And we're going to use this as an ease out curve, so we can just do this, twirl the default value open, and we can say minus 0.25 there, and this should be 0.25, which it is. So that's all set up, and we can just hit OK. Fantastic, so we've got that user data in. We can then say spline is equal to, and bring in our user data, and we can simply say op cbody.userdata 1 id user data 1, and that will give us a spline ready to use a bit later. The final thing we need to do for this initialization step is to define some global variables. So global, and it will be start time, so start underscore time, trigger, and finally RND for our random value. And that completes this initialization step. We've got all of our variables and other bits and pieces that we need. The next thing that we need to do is work out what's going to be happening at frame 0. So let's do that next. We can say if frame is equal to 0. Now, avoider dot set absolute, or ABS for absolute, pos, and then we can put a vector in here. Now at the moment, as we can see, we've got our avoider positioned at the center of the world. So what we can do is set this up so that we can always make it there at the beginning of the animation. Now these lines I'm going to put in here, there's going to be 2 of them. They're purely optional. You can always comment them out if you don't want them there, but we'll put them in anyway. So we'll say c4d dot vector, not in caps, vector, and it will be brackets 0, 0, 0. And that sets the absolute position of our avoider. Now we can copy this line, just copy it from there, that's better. Paste this in here, and we can simply change absolute position to absolute rotation, so ROT. And that will set the absolute rotation to 0, 2, so it will be where it is now. As I say, these 2 lines are completely optional. You don't have to use them. Moving on from here, we can say trigger is equal to, and it will be 1. Start underscore time will be equal to -1. And random, or RND, that will be equal to -1. And that sets things up at frame 0, and we're ready to go from here. The next step for us is to create the part of the algorithm that deals with the rotation of the avoider. So we can come down to here and type else, and then we're ready to move on. Our first line will be if, and it will be RND is less than 0, which of course initially it is because we've set it to -1. So this will be used here. We can then say RND is equal to, just make sure we get that in correctly, RND is equal to, and it will be random dot uniform, and we can give ourselves, if I can spell uniform correctly, we can give ourselves the option to go from 0 through to the length of our list of cubes. So len brackets cubes, and we must take 1 off, so -1 close brackets. We need to take -1 off because of course we've got 50 cubes, but the first cube will be cube 0, and we're going from 0 to 50, which is 51, so we must take 1 off. Our next line will be at this level, target is equal to, and it will be cubes square brackets random, so RND. So whatever cube we've chosen, that's what we want to be our target cube. Our next step is to work with matrices. Now, what we need to do, if we bring in on our Python tag here, or our Python null here, if we bring in an Expresso tag, we can come into the system presets, and with our calculations, we've got target in here. Now, this target is actually a Python coded target, and it works in exactly the same way as the target tag. It does exactly the same thing. Now, if we come into here, we can see we've got the code over here, and we need this code. This code is going to be very useful to us. So what we're going to do is copy it. Now, I would give a shout out to the person who created this, but it's not credited to anybody. But whoever you are, many thanks for doing it, because this is very, very useful to us. We don't need the global rotation because that deals with this output here. We're not interested in that, but we are interested in the rest of it. So if we just select all of this and copy it, we'll paste it into here. And then we can think about doing some work with it. We've got to adapt it to our needs. So let's just make sure that we get everything at the correct level. And that looks perfectly good. So for a start, object matrix, it won't be object matrix, it will actually be a voider matrix. So let's change that, a voider matrix. Target matrix is fine because we've got the target here, so we can leave that as it is. The next two lines are also fine, except that we need to change object once again to a voider to get that correct. And then we can look at what we've got going on down here. Now, everything here is looking good. We don't really need to change anything. So we're generating a new matrix. We're getting the offset vector of the matrix, and that's going to be equal to position 1 because P1 and P2, they're the position vectors. So we've got a position vector of our avoider, and whatever cube we've chosen is our second position vector or from our matrix, because they're both offset vectors. We're then working with cross products. So we've got matrix.v1, it's equal to position 2 minus position 1, and we want the cross product of that vector. And this is how the actual target works. It literally creates the cross product of two vectors and uses that to make something point along its z-axis towards the object that's actually been chosen as the target object. It's very clever. Don't ask me how it works. It's a mathematical miracle to me, but very, very clever. So we've got those two cross products, and then our third vector is simply a normalized vector, so a vector with a value of 1. That's all that is, and that will be the z-axis that points towards the chosen object. And then our rotation here, we've got a rotation value here. I'm going to change the capital R to a small r because we will be using this. So it's equal to literally matrix to HPB and matrix is what we're going to be using for that. So what we've created up here is what we're going to be using to actually do this. So this matrix, the new matrix, that's what we're going to be interested in. And then the old rotation is equal to the object matrix. So our initial position, so the position we're in now would be our old rotation. The new rotation would be looking towards whichever cube is chosen. And then we've got rotation.z and old rotation.z. So our rotation z is equal to our old rotation.z. That's being passed to in order to, I think, make the thing look at the actual chosen cube. But in actual fact, we need to do some more work here, because this won't actually give us the result that we want at the moment. It will actually make this thing look between two cubes rather than directly at one of the cubes. So we've got to do a little bit more work and a little bit more enhancement here. So let's have a look and see what we can do. Now, we can move on from here because that code doesn't need to be doctored anymore. Everything there is okay. Now let's just double check that though. The one thing I do need to do, a couple of things I've forgotten, is just here. We've got to just change this. So I've got to say avoider dot matrix, and this target just simply needs a small target or a small t on the word target. And that now should be working as it needs to. If not, we'll find out. It'll give me an error message a bit later and we'll have to do a little bit more sorting out, but it should be fine. Right, moving on from here then, what we want to do is choose a cube, which we're going to do with our random here. We're going to be choosing a cube. We then want to make the avoider here turn to face that cube, which is obviously using this, but at the moment all this is giving us is the angle that we need to rotate around in radians. We need to use that angle within a range mapper to make this turn over so many frames, and that's what we're going to do next. Let's see what we can do. So if trigger is equal to 1, and of course initially it is, so we're going to be using this piece of code. We can say if start time is less than 0, and once again we've set start time to -1, so it certainly is going to be less than 0. We can say start underscore time is equal to frame. So whatever our frame value is, we're going to be taking it and putting it into our start time. Moving on from here, we can say duration is equal to frame minus start time, thereby giving us a 0 point no matter where we are along the timeline to start from. We can then say if duration is less than 15. So I want this avoider to rotate over 15 frames. Our next line, range mapper, the ubiquitous range mapper. Range mapper is equal to, and it will be c4d.utils.range map, open brackets, duration 0,15. So we've got duration as our input value, and we've got our input range between 0 and 15, which is what we want. We can then say, now this is where things get interesting. We need to work with old rotation and rotation, but we're interested in old rotation X and rotation X because they're the ones that actually make this work correctly. So if we say old rotation dot X comma rotation dot X comma, and then it will be false. We don't want to work with true. And finally spline. That gets our range mapper set up, and it will work as we need to and make this rotate towards the cube that's been chosen, whichever one it may be. And of course, we can rotate this way or we can rotate in the opposite direction. So it gives us 2 options, which is great. I like the way that works. Moving on from here, we can say rotation is equal to range mapper. And then finally, in fact, it would help if I spelled rotation correctly. It needs another T, that's better. Rotation is equal to range mapper. And then finally, avoider is equal to, not equal to, dot set ABS rot. And it will be brackets rotation. And that finishes that part of the code. Let's see if it actually works. Right, we've got a problem here. That's not been closed. Okay, so I just need another bracket. What line is that? Line 30. Yeah, I just need another bracket on the end of there, and I also need one on the end of there because they're both wrong. Okay, let's see what happens now. Go back to 0 and just run this. Oh, we've got a problem. Okay, line 40. Let's have a look, see what we've got in there. So, where are we? Target is equal to cubes, bracket R&D. Well, there shouldn't be a problem there. Let's have a look. It must be integers. Well, they should be. Random.uniform. Where are we? Random.uniform. Should I have used random? Oh, I've used uniform. I shouldn't have used uniform. I should have said randint. Randint. Random integer. That's what I should have used there. My bad. That's my fault. Okay, let's see what we get now. We've still got a problem. Right, line 55. Where are we? Old rotation. Let's have a look. Object matrix is not defined. Where are we? Line 55. Yeah, object matrix. It should be, where are we? Avoider matrix. Easy to do when you're doctoring code. Right, so avoider matrix needs to be in there. Let's have another go. And we've still got a problem. So line 56, where are we? Rotation Z is equal to old rotation Z. Right, probably needs a small letter on there, so make that a small r. It's just little things. Line 68. Let's have a look and see where we are here. Let's have a look. It must be vector, not float. Rotation equals range mapper, so let's have a look. Oh, sorry, it should be rotation dot x is equal to range mapper. Let's see where we go from there. And now we've got it. We can see that that did move. Yeah, so make sure it's rotation dot x in there, not range, not rotation. But yeah, there's a few errors that I made in there, but that's mainly because I'm copying code and doctoring it. It's always difficult to sort of work with that. But I just wanted to show you it because I thought it was well worth showing you that this code is available to you and that you can actually adapt it to your own needs and make it work in different scenarios. But yeah, that's all working fine and we're getting what we want now, which is nice. So we're getting subtle movements or we're getting quite, large movements depending on what's going on. Great, so all we need to do then is just finish this off and we can say else at this level. And it will be trigger is equal to 0 on this occasion and start time is equal to -1. So once we've actually used this piece of code, we want it to be switched off, which is why we've set the trigger to 0, because the trigger has to be at 1 before anything happens. Okay, fantastic. So let's move on and we'll think about making this thing move towards the chosen cube and avoid colliding with it. We need to be level with the if, so we're at this level here and we can type else. And then we can think about the code to make this thing move. So for a start, we need to create a difference vector. So diff_vect is equal to, and it will be avoider dot get absolute position minus target dot get absolute position. So we're getting the difference between our avoider and our chosen cube. And then we need a distance vector, so we need to measure the length of this difference vector in order to get the amount of travel that the avoider needs to do technically. And you've seen me do this if you've seen some of my Python effector tutorials. We've used a similar setup in those. So dist underscore vect is equal to, and it will be diff, if I can spell it, diff underscore vect dot get length open close, and that will give us that distance value. Moving on from here, we want to check the length of our distance vector. So when we're getting to the stage where we're almost in front of our chosen cube, we will want our avoider to stop. We don't want it to collide. So that's what we're dealing with next. So if dist vect is less than or equal to, and I'm going to say 50, we can then say trigger is equal to 1. Start underscore time is equal to -1. And RND is equal to -1, because we want this to be used again at that point. So we want to choose a new cube, and then we want to rotate the avoider to face in the direction of the new cube. And that's what we're setting up here. And of course, we want the trigger to actually use the range mapper and move the thing again or into that position. It's got to be rotated into that particular direction. So that's dealt with that. We can then say else, and it will be start pos is equal to, and it will be avoider dot get absolute position open close. We can then say AX, so avoider's X axis. That's what we're interested in, because in order to make our avoider move towards our cube, it will be moving along its X and Z axes. So that's what we're working with here. So we can say AX is equal to, and it will be start underscore pos dot X. And then we can simply copy this, paste it in here, and we can say AZ is equal to start pos Z. That's what we want there. So we've got those two vectors. Now we also want an end position, and that will be the position of the cube. So end pos will be equal to target dot get absolute position open close. And we can then say tx, so the target's x position, is equal to, and it will be end underscore pos dot x. Copy these two, or copy this line I should say, drop that into there, tz pos dot z, and that gives us those two vectors. Fantastic. Now we can use a second range mapper. In fact, we've got to use two more range mappers, because we need one for the x-axis and one for the z. So we can say if start time, so we're using the start time variable here too, and that's fine, it works okay, because we're only going to be moving and we're not going to be rotating at the same time, so we can use the same variable. So if start time is less than 0, we can say start time is equal to frame, giving us that 0 point to start from once again. And then, as before, duration, and it will be is equal to start, or rather it will be frame minus start time. Frame minus start underscore time. And then from here we can work with our range mapper. So if duration is less than, and I'm going to say 60 on this occasion, so I want to work with 60 frames for our movement, and then it will be range underscore mapper underscore x is equal to c4d dot utils dot range map duration, and then it will be 0,60 for our input range, comma tx, rather ax, I beg your pardon, comma tx, comma false, and once again we'll use the spline. So that vectors us along our x-axis, wherever this may be pointing, because obviously our z could be pointing over here, so our x would be somewhere here, and we're going to be working with that. So that's that done. We can copy this line, just paste it in here, and this time it will be underscore z, so this is our z axis range mapper, and here we can say a z and t z, and that's as much as we need to do there. So we've got both of our range mappers set up and working. Our next lines, we need to do a vector to reals technically, so we've got to say x is equal to, and it will be range mapper x, and y will be equal to 0, because of course our avoider doesn't move anywhere along its y-axis. And then finally we can copy this, drop it in here, and say z is equal to range mapper z. And then our last line of code will be avoider dot set abs pos, so set absolute position, brackets, on this occasion c4d dot vector, brackets, and it will be x comma y comma z, double close. And all things being fair, if I've not made any mistakes, we should now get the result that we want, but let's see if we do. And look at that, we do. Let's give ourselves a few more frames, we'll make it 1000, and we can see this thing really scoot around. Fantastic. And it gives us a nice result, doesn't it? It works really well. I mean, I've found this really inspiring. I've got a number of ideas for making this more enhanced and for things that it could be useful for. So expect to see some more tutorials using this code and some more besides to make it more interesting. But yeah, it really does work nicely. Now, as I said earlier, these two lines, they're both optional. So let's just take those away. So now when we run the timeline, our avoider is going to start here. It doesn't care. You know, you can stop it here, bring it back to 0, and it will just work from wherever it is. So entirely up to you. You could put some more user data in to switch this on and off if you wish to. You could just have a bool there and then say if the bool is checked, use these two lines, otherwise they just get ignored. You know, you've got the option for doing something like that if you wish to. But yeah, totally up to you, whatever you choose to do. But yeah, I'm really pleased with how this came out. I thought it's really fantastic, and it works really beautifully. And it's so simple, really. I mean, it's just 3 stages in the code. I mean, you've got the initial setup here, a piece of code that handles the rotation, and a second piece of code that handles the movement. And that's all it is. And just using cunning logic, really, with the trigger, you make sure that it rotates when it needs to and it moves when it needs to, but it doesn't do both at the same time. You know, it's a really good setup, actually, for doing that. A really nice piece of code. But yeah, and that about brings us to the end of the tutorial, because that's what I wanted to show you in this one. And as always, I really do hope you've enjoyed this one and that it's inspired you. As I say, it's certainly inspired me. And if you have enjoyed the video, please give it a like. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one. So I'll see you very soon on the next tutorial.